session number 3. Hope you had some time for a good coffee. So please don't forget, if you have any questions, post them in the Q&A. And also don't forget to rate our sessions. It's always interesting for our speakers to know how you liked their session. So our next speaker here at stage 1 is Koen Rottiers, and he's going to tell us a bit more about CI and CD for the data platform. Koen, good luck.
Thank you. Welcome everybody at my session. So CI/CD for a data platform and how to enable data pipelines or consistent data pipelines. So first of all, who am I? My name is Koen Rottiers. I'm a senior consultant at Codit. So my colleague Tom Kerkhove was before me with his session. So colleagues with him since the beginning of this year. I've been 9 years in IT, which most part track record in networking and infrastructure. So moving focus a bit into the different part of the spectrum of IT than previously. My goal is to combine people, business, and technology to deliver solutions that give value to everybody, to business, to people, to make life more enjoyable. You can follow me on Twitter at Koen Rottiers if you want to have some insights. Please do so. So it's my first time doing a public speaking session. I hope you will enjoy it. If you have feedback on the session in general or at my speaking abilities in general, please let me know after the session. So first of all, a data platform. I think it's not yet clear for everybody what exactly a data platform is, but a data platform is a central place where a company can store data from all of different sources they have. That can be external sources from external parties, that can be internal sources from internal systems like SAP. It can be external providers, external data source providers that can add value for your data. And you want to centralize it and want to have a centralized data store to store all of that data that is valuable for your specific business. So as you can see, you will have a flow from data coming in, getting stored, getting modeled, getting prepared, and then getting presented to your data consumers. So on the left, you have data providers, which can be APIs, which can happen through messaging, can be sourced from databases. And then you ingest that data into your data platform. Data ingestion can happen through 2 different ways. You can have real-time data ingestion and batch data ingestion. So messaging and API are good examples of real-time data ingestion. And running an export from a database or querying the database itself is most of the time done in a batch fashion. In the data platform, you have 3 different types of data stores. You have an interactive data store, so the general database systems, those SQL database systems. You query through an API, for instance. Then you have your analytical data stores at the bottom, so where your BI people run their reports. You have a data warehouse that stores all of those different data sets where your data scientists can run their analysis on the data set you have. But central in that piece, you have a data lake. So the data lake will gather all of your different data you get from different sources into a central place that can be used for both your interactive data store and your analytical data stores. You can see that happens through a step in data preparation. So data that got ingested into your data lake, sometimes you need to clean it, you need to curate in a fashion that it's usable in your interactive data store or in your analytical data store. So that can happen in real time or in batch as well. yeah, of course, you have your data access through APIs, so you can present your prepared data, data that you ingested, that can have additional value for your data consumers. And then at the bottom, you also have, of course, AI and ML, which is a hot topic today, which can be presented to your data consumers. And data consumers can be anything. It can be integration of your front-end application or mobile applications. It can be connected to B2B, so you have your additional data sources for your SAP environment to get additional information in there. It can be that you have delivered additional information for your end customers that you have combined. So as you can see, you have a possibility to have a wide range of inputs and have a wide range of outputs in your data platform with the data lake as a central store. So Azure Data Factory. Azure Data Factory is the core component in a data platform if you're doing it on Azure. For people who don't know what Azure Data Factory is, Azure Data Factory is an orchestrator. It orchestrates how data gets ingested, flows through, and gets outputted in a separate destination. It has connectors to a lot of different data sources, both cloud and on-premises, so you can connect from your data factory into SharePoint. You can connect into OneDrive, other cloud services, Salesforce are also applicable, but you can also connect to your on-premises data stores. So for instance, if you have a SQL database running on-premises, it's possible that you make a connection to your SQL database and ingest data directly from the SQL database. So it can connect to different data sources for their ingestion, but also for the output or for intermediary steps. Then there are two different types of flows that you can use, data mapping flows and data wrangling flows. So by default, when you move or when you use Data Factory to move data from your ingestion into your data lake and then output to another destination, you don't really do a lot of changes to your data sets. With data mapping flows and data wrangling flows, those are concepts that are used in Data Factory and give you the possibility to have changes to your actual data as it's moving through your Data Factory. So if you want to do some actual hard cleanup actions, then data mapping flows or data wrangling flows can help you with that. It's possible to integrate external compute within your flow. So if you have a flow coming in from a database, you ingest it in your data lake, and you want to do machine learning on top of your ingested data set, you can integrate to Databricks with Azure ML. If you have a certain Azure function that combines data sets, then you can call the Azure function to perform its action, and then when it's finished, you will call back and you move through the actual data pipeline. So as you can see, the core here is that Azure Data Factory is the orchestrator of your whole data platform that links every component together to deliver your data flows. So to map it to the scheme I previously presented, so the place in the data platform with all of the different Azure components here. So you have your data providers to the left, where you can see, of course, messaging, API, app services, streaming can come from IoT Hub. You have your database systems. Your data ingestion if you're doing real-time data ingestion, don't do it with Data Factory. It isn't built for that. But use Data Factory to call a logic app, to call a function, to ingest your data in real time, or use a function or logic app to place your ingested data in real time into a landing zone. Whereas if you're running in batch, running from an export that's located in an FTP location or connecting directly to a database, then Azure Data Factory can connect directly to those locations to ingest all of those data sets into a landing zone. So as you see here in the middle, the data lake itself, we have a landing zone, a raw data zone, and a curated data zone. So a landing zone is just where you take the data and you put it into your data lake, but you don't do anything else. With raw data, you can already add some metadata, and with the curated data set is really your cleaned data that is usable in your analytical data stores or your interactive data stores. So in the center, use Azure Data Lake storage accounts to facilitate those different zones. And as you can see, your interactive data stores and your analytical data stores use their own set of Azure resources. And then again, for your data preparation, so you clean your data, it's located in your curated zone. Of course, you need to send it out to your interactive data store, to your analytical data store. Again, in most cases, Azure Data Factory can facilitate that move for you, but you can also use Azure Functions, for instance, to call external providers. And then again, you can have, for instance, Azure Databricks or ML to do your Azure machine learning or artificial intelligence, have your APIs exposed through API management to have all of your valuable data to your data consumers. So the data lake architecture itself with the different components, you can see an overview here. It's a high-level overview. It doesn't have all of the different detailed components on there, but I'm going to walk you through so you have insights on what actually is needed when you're running the core of the data platform. So as you can see, again, Data Factory is in the core, orchestrating all of the things. We have at the bottom the different data lake storage accounts, so a landing zone, a raw data lake, the curated zone, and we can also have an output zone where, for instance, external systems can pick up their specific data set and ingest it in their system. We have a managed identity. So every single data factory, when you create a data factory, automatically has a managed identity assigned. So that managed identity represents your data factory in your Azure Active Directory, which gives us the possibility to use that specific managed identity to give access to all of these different storage accounts, which alleviates the need to put the connection strings of the storage accounts or the data lake storage accounts into, for example, a key vault. However, you see a key vault on top. A key vault is being used to store your secrets for your external sources or your external destinations. Again, the managed identity here is being used to access the key vault. So the managed identity has access to the key vault, and automatically Data Factory can pull from the key vault the right connection strings to connect to a resource or an outside source. I've put transformation fairly separate over there. transformation can be done, for instance, if it's not possible with the tools you have in Data Factory with data flows, data mapping flows, or data wrangling flows. You can use an external tool like functions or like Logic App. So if you're experienced or you have a current investment and you have a function that does some data cleaning, then you can reutilize that function in your entire data flow. So it's perfectly possible to integrate that. Then we have 3 outgoing connections. So if you want to go out to an external connection or source that is publicly available, then you can use an API connection to connect to SharePoint, to connect to Salesforce, things like that are publicly available endpoints. Of course, it can be that you need to use an API key or some other secrets to gain access to extract data, but that can be stored into your key vault, and then you can use those secrets to actually connect and extract information. Then you see for customers running express routes, you can access, or in this example, it's an express route, but of course it can be any other VPN connection as well. So if you want to access your on-premises resources, your on-premises data sources, I think a lot of customers have different types of data sources still remaining on-prem that can be valuable when ingesting in your data platform. It can be connected up into your data lake. I will go more in detail on that because it's really specific. But there's a possibility to connect your on-premises data sources into your data platform. And of course, it's also possible. So if you have already, or your customer or people have resources running in Azure, which are VNet integrated, it's also possible to access those resources in the same fashion. And last but not least, on top, you see Azure DevOps. As you need to enable CI/CD, you can integrate your Azure Data Factory with Azure DevOps to fully facilitate CI/CD for the entire data platform. So to go in more detail in running or connecting to your on-premises resources is integration runtimes. So you have Data Factory, and you have something that needs to do your hard work in actually doing all of the different steps. You have 2 things. You have an Azure integration runtime and you have a self-hosted integration runtime. An Azure integration runtime is just a pool of resources, public resources that can be used to reach out to publicly available endpoints. This means that when you want to reach out to an on-premises data store or something that is not publicly available, that it is behind the firewall of the enterprise network, then you will need something that is called a self-hosted runtime. So a self-hosted runtime is something that you can run on a VM that will register itself to your data factory and will do all of the heavy lifting in getting your data from your on-premises data stores into your data platform and be able to source for machine learning, for instance. Of course, you have the added complexity that you need to manage your virtual machine that hosts the self-hosted runtime. But that self-hosted runtime, of course, needs to be connected into your networking infrastructure to be able to connect to all of these different resources. So why do CI/CD for a data platform? First of all, I want to show the different roles and responsibilities there are when running a data platform. So you have a data platform owner. So this person is the owner and responsible for the overall data platform. I think at a lot of companies, you see data management teams coming up that get the responsibility of all the data estate that a customer has or a company has. So typically they will be the data platform owner. Of course, when you have a data platform, you have to have somebody that operates the data platform in a day-to-day basis, do some operational tasks, see if everything is up and running, if there aren't any issues connecting to different data sources. It can always happen that a specific connection to a data source is offline. So getting everything running up in a daily fashion and delivering value to the business, that's the responsibility of the data platform operator. Then you have data pipeline owners and data pipeline developers. Typically, when running a data platform, most of the time there will be a business case that the business needs to have some insights or needs to have certain data sets combined to deliver certain insights to a specific business unit or for the whole business or the company. So the requests will come to the data team, and a data pipeline developer will look at that request and will be actually developing the new pipeline to make sure that data gets ingested from different sources and delivers the data set that is needed for BI to run their analytics on top of it. So typically the data pipeline owner will be the business unit or the BI team that is requesting the specific functionality. And then there will be a developer actually building the data pipeline. And then last but not least, an important step here is as well that you always have a data source owner. So in times of GDPR, which is fairly important these days, you have a data source owner. So when you're connecting to an external data source, the data that is hosted in that source is owned by somebody, that person needs to determine the access rights, the access manner, what encryption is needed, which data can be extracted. Sometimes it's not allowed to extract data from a data source. So when the data pipeline developer and the data pipeline owner want to add functionality or want to expand their data sources, it's always necessary to talk with the data source owner. Most of the time, this will be an application owner of the data of the application that owns the data or generates the different data sets. So these are the different data platform roles and responsibility that you have and are crucial in running a data platform. So, but why do CI/CD for a data platform? Key advantages here is you get consistent deployment of data pipelines. I think in most cases, it's still a manual process in having a data pipeline developed or a data system that moves data from one place to the other. If having an ETL pipeline, for instance, is still fairly manual in moving it into the different environments. So having a consistent deployment of your data pipelines across environments is key to have real production ready materials. When you do CI/CD, you could create your different environments. You can have dev, test, acceptance, production, no matter what. And you can do full testing of your data flows into your data lake. So if you want to test your data flow or your data pipeline that has been developed, you can do it in your own environment where you don't have impact to anybody else or to production. So you also have better collaboration. So most of the time now, a data engineer the DBA admin or people like that are in a data function currently live in their own island. Having CI/CD and having a similar process than application development enables better collaboration, enables quality insights into, okay, that person of my team has developed that feature. We can review it together in the process that, yeah, everybody knows in application with PR reviews and all of that stuff. It's also easier to track your feature development. So when an additional feature is requested by the business, some data sets need to be adjusted, additional data needs to be ingested. That can be tracked like you do with your application development. So you can see when a developer has taken on the task to develop the feature and when it's moving through the different stages in your application or your data pipeline lifecycle. Yeah, you can have pipeline quality review. So when somebody develops a pipeline, of course, it needs to be up to the standards that are defined in the team or within the company. So working within a CI/CD fashion, that can be issues can be found early on in the process and not when something is in production. Of course, more fine-grained data security. Data security, I think, is also a hot topic today. You don't want to have developers accessing real-life production data sets. You want to have them test and play around with a certain mock data set or with a subset of your data that is allowed to be seen by developers. But in most cases, and certainly if you're working with personal information or with information from hospitals, for example, then you don't want that developers give or have that access to that specific data sets. So with CI/CD, you can only have developer access to your dev environment and move the feature that they have developed into your next phases without them having access to the actual data and having insights in that data. And the last one, you can track your data movements across your entire data estate. So when your data platform is a central piece of your data lake or your data estate, then you can see, okay, I have all of these different sources where I extract data from and I put them in a certain place that they can be consumed for APIs and things like that. So you always have track of your data as it moves through your data platform. So Azure Data Factory Git integration. So by default, Azure Data Factory isn't Git integrated, but you can enable it to have it integrated with a Git repo. It's a bit of a special Git integration, so I'll explain it in this part. So Git, like you know it, you have a main branch, you have your working branches, development branches, you have different branching possibilities. So you have your collaboration branch, so your master branch. So when people are working on a feature, they create their own branch, develop their feature, create a pull request, and then merge that feature into your collaboration branch when everything is good. Then there's a special step here. There's something called a publish action. So when you publish your content from your master branch into your actual configuration of your Azure Data Factory development environment. What happens behind the scenes is that your configuration that is automatically stored in your master branch gets translated into real ARM templates that are usable to deploy your configuration. So from your Azure Data Factory dev environment, you publish and you create those ARM templates in a publish branch, which is ADF publish. And with that specific content in that specific branch, you can use that ARM template to push your release into the next environment. So you push those ARM templates to your test environment. If everything is okay, you can move it next to the ADF production environment. So as you can see, the only data factory environment or data platform environment that has integration with Git is your dev environment. Test, production, acceptance, no matter what additional environments you have, are not integrated with Git. So configuration there remains within Azure Data Factory, but of course is based on what you have defined in your dev environment. So when you're running a data platform, to have a certain structure in your repositories and your different branches, so I split it out in two different repositories because for me, you have at one side your data lake infrastructure, and on the other side you have your data pipelines themselves. Your data lake infrastructure repo holds everything that actually deploys your infrastructure. So data factory, your storage accounts, your key vault, all of that stuff is only stored in your data lake infrastructure. I store it in a separate repo because the data pipeline developers shouldn't need to worry about your actual data lake infrastructure. They should be able to focus only on developing data pipelines. So to keep it aside, every configuration regarding the infrastructure is in the data lake infrastructure, with, of course, your main branch. And when you have to make some changes or add some features, then you can have a feature branch and then follow that process. And aside from that, you have a data pipelines repo. So your data pipelines repo is the actual repo that gets connected into your Azure Data Factory. So Azure Data Factory, from the moment you connect it, uses that specific repo to store its configuration and automatically creates the ADF publish branch. So that specific repo is fully, more or less, ingested by Data Factory to be used as their configuration store. As you can see here, we have three different branch types. So we, of course, have a main branch, the master, where all of the main configuration is stored. We have a feature branch. So for instance, here it's school data ingestion. So if somebody is developing a feature to ingest data from different schools to be able to have a general overview for the business, you can do that in a feature branch, and then you can merge that feature into your master branch. From the moment that you're ready to release your actual dev environment configuration, your master dev environment configuration into the next environment, you need to publish that configuration into the ADF publish branch. With that content in the ADF publish branch, you can move your configuration to the next environments. So crucial here is the ADF publish branch. That's something special in this setup. All right. I'm going to show you in Azure Data Factory and Azure and Azure DevOps how this all comes together. So we have Azure DevOps with a single project, Azure Data Lake. I'll first show you the different repos. So we have a data lake infrastructure repo, and we have our data lake pipelines repo. So our data lake infrastructure repo holds all of the different ARM templates that are used to actually deploy your infrastructure. So I have two different ARM templates here. So I have an ARM template that rolls out the entire infrastructure, and with entire infrastructure, in this case, it's the data factory, it's the key vault, it's the storage accounts that all get deployed automatically. The managed identity of the data factory gets access to the storage accounts to be able to connect to them. Everything is done automatically in this case. So as you can see here, all of these different, so the top level resources here, except for the virtual machine here, but all of these different resources are automatically deployed and connected together with that specific ARM template. There is one additional ARM template. So we have a self-hosted integration runtime virtual machine resource. This isn't always needed. So this is needed in the case you need to access on-premises or private data sources. So what this template does is actually provide the resource, so a virtual machine that can act as an integration runtime that has access to your on-prem resources or your private resources. So as you can see, we also have a specific Azure DevOps pipeline that deploys all of these infrastructure parts to the different environments. So we have, in this case, a resource group data lake dev, and we have a resource group data lake production. From the moment everything is deployed by the infrastructure here, you can see all of your different resources, and you have a different portal for Azure Data Factory. So adf.azure.com, and you have your Azure Data Factory portal. When your data pipeline developers are onboarded, you need to give them access to both your data factory, but as well to your Azure DevOps project. So that's crucial when you have enabled Git integration. Make sure that they have access to the project, Azure DevOps project, and to Azure Data Factory. Let's go from here. So if you select your data lake, then you can use author and monitor as well. So that's also a possibility to access your data lake or your data factory portal. So this is the data factory portal. You have some author functions here. And here you see that you're integrated with Azure DevOps Git, and you're currently on the master branch. So here we have our data pipelines repo. So this data pipelines repo is connected to your data factory. So in the configuration here, you have Git configuration, and you can see here that I'm connected to that project and to that Git repo, and my collaboration branch, so where every developer is collaborating or their features get merged into, is your master branch, and you have your ADF publish branch. Of course, you can use other names, but that's always possible. So what's inside of a master branch? So here I already have two data sets here available. A data set is a representation of your data source or subset of your data source inside of your data factory. So when you're developing here and your configuration is stored in Azure DevOps, configuration of your Azure Data Factory are all JSON documents, but there aren't ARM templates. So as you can see here, for instance, you have the data sets here. I can see a JSON document for my dataset raw and my sample dataset. So as you can see here, that's just a regular JSON document, but it isn't an ARM template. Very crucial that it's specific configuration for your data factory. So we have this here. Let's start and show how a data pipeline developer would use this setup to move their developed feature into the next environment and then to how to develop additional features. So as you can see here, we're currently on the master branch, but of course, we don't develop additional features on the master branch. We want to create a new branch. So from the slide here or from the actual portal, you can use or to create a new branch. So let's create a new branch, save, and automatically your configuration is branched off the master branch. Everything you do now, of course, is stored into your own branch. So when somebody is developing new features, a data pipeline developer is developing a new pipeline, they can add a pipeline here and they can start doing their building. Of course, like you saw, all of this configuration is JSON. So everything is stored in JSON. So everything you drag and drop here is stored in JSON. So if I have a copy action that I add here, you see it's visual here, but it's already added in the JSON document behind the scenes. So first of all, I have a pipeline that I already built to make it quicker that I can add here. Okay, I can't rename, so I need to call it pipeline 1. Okay, so there is my copy with all the configuration that was already in the JSON document. This is used, for instance, if you want to use templates, you can templatize your pipeline or your data sets. So data pipeline developers can reuse the standards that are used in your specific company as well. So that data pipelines don't need to reinvent the wheel all of the time to deliver value. So we have this data pipeline. This specific data pipeline just does a copy from one storage account to the other. So in my landing zone, I have a file or I have a container that contains, so we have container ingestion. It contains a folder with a sample file. So as you can see here, that specific action here, the source is the ingestion from your landing zone, and the sink will be the raw zone. So when we debug, so as you can see, you can debug your entire flow. When you debug, the respective integration runtime to reach out to that specific data source or intermediate data place will be used to move data from one way to the other. So as you can see here, let's have a look into the raw zone. So if you go to the raw zone, we can see we have a container. In this case, it's insurance. We have a folder, and we have our data file that just has been moved from one place to the other. So that's all working. We're happy with it, and now we want, of course, save our pipeline. And of course, we're currently working on our demo branch, and we want to merge that into our master branch. So from this view, we can create a pull request. When you click that button, you get redirected into your Azure DevOps environment, and you can create your regular pull request. I think that everybody knows how to do. You can create and add your reviewers, give the additional explanation on what actual value has been added or what feature has been added. You can link it to work items. So having that traceability is built in into this flow. So we create our PR. It's already checking if there are any issues. And as you can see here, in my PR, it's just the pipeline document, JSON document that represents my pipeline that I have developed. So when everything is done, everybody approved, everything is up to standard, to the quality standards, of course, you can complete your pull request. So when you complete your pull request, everything is merged, your configuration is merged into your master branch or your master location. So as you can see here, currently I'm still on demo branch, but that has been deleted automatically by my PR. So let's go back to master, save, and my pipeline is automatically in my master branch, which is logical. Of course, everything is go. The data platform owner gives the go to move the additional feature into the next environment. In this case, in this demo, it's a production environment, but in most cases probably there will be a test or acceptance in between. But we've got to go to move this configuration into your next environment. To do this, you have this publish step. So for the moment, it's not yet fully automated, but you still have to click a physical button to actually run the publish step. So when you do your publish, it's getting all of those different configuration files. It notices there is something new. In this case, it's a pipeline. So you can verify what changes will be published to your publish branch. You can click OK. And then those specific ARM templates get deployed or get configured. So if you look into the ADF publish branch, so this is the regular master branch where all the regular configuration is stored. Here you always also see your ADF publish branch. So you have ADF publish here, and your structure is fully different. So we have, in this case, your data lake name with all of the different ARM templates that are needed to actually deploy that configuration through or with an ARM template. So here you can see your ARM template itself. So automatically, Azure Data Factory creates the real ARM template that can be used, and with parameters and variables that can be overridden when you move to your next environment. So as you can see here, you have your connections that are hard-coded as a default value here, but those can be overridden when moving to the next environment. So if you have a look at our pipelines, so we have 3 different pipelines. So of course, a pipeline to deploy data lake or data platform infrastructure for every environment. And then we have 2 different pipelines. We have a pipeline that deploys the data lake configuration to the next environment. And I also have a data lake common components pipeline. What this pipeline does is deploy, for instance, the agent of the self-hosted integration runtime, so it registers automatically with the specific data factory. But things like functions, logic apps that are used by your data factory but are external to your data factory can, for instance, be deployed from your common components pipeline. And then on top, you see that my data lake configuration pipeline is waiting. Of course, if we're deploying to production, we want to have some approvals before we move to production, and certainly in the data platform. So there's an approval on the production environment, and you can see that it's automatically triggered when my ADF publish branch has been updated. So, but first of all, I'll show you. I'll switch environments here. So we go to the production data lake or data factory. And as you can see here, yeah, there was already a pipeline existing, but my pipeline 1 is not yet here. And my configuration here isn't integrated with Git. It's purely local. It's in the Azure resource itself, that configuration. So there's nothing yet here. So from the moment here, we approve. So we review all of the changes, everybody that needs to approve. It can be an external process as well, depending on the company request. But you can approve here, and from the moment we approve, my release to production starts. So as you can see here, different steps. What I actually do is just a regular deployment of ARM templates to Azure. And with that deployment of Azure ARM templates, my configuration is deployed into the next environment. So in most cases, you will have those different steps where you have your build phase, where you do some analysis and you get your correct artifacts. And of course, aside from releasing directly into production, you will have an additional environment. So let's wait until everything gets deployed. Something important, I'll swap just back to the dev data lake. So as everything is stored in JSON documents, sometimes when you add things like a linked service, so the linked service is your data source itself, or a function or a key vault, something external. Then when you add a linked service, at that specific time, you need to run a publish. So be aware when doing actions like this, and you add a linked service, and you need to, because you add a linked service, you need to run the publish step, that your pipeline in moving your configuration to the next environment will be automatically triggered because of that step. So some in your regular pipeline development, it isn't the case, but when you add linked services or an integration runtime, it can happen that the ADF publish needs to be triggered. So my production has been deployed. Let's switch back to production, data factory. So magically, my pipeline 1 is here. It's ready to go. It's the same as in my my development environment. It uses the data sets here. As you can see, my storage accounts or my data lake storage accounts are specifically connected into my production environment and not in my dev environment. So normally, if everything goes to plan, I have my, I'll show you here, in my production resource group, we have in the landing zone a separate container like we have in our dev environment. We have an ingestion container with a sample file that will be copied into, should be copied into the raw zone. So there's nothing yet into the raw zone. So here, I think in the raw zone, there will be a file path here. So normally if we run it, it will be automatically created. So we can debug here as well. So it's still possible in your acceptance or test environment to run a debug, to run or test the actual pipelines. So as you can see here, we developed something in dev and we moved it into production. Automatically by the click of the button, we can run our pipelines there. It's all linked together with production resources. So as you can see, it enables data pipeline developer to or a data engineer on delivering value and insights to the business and let them focus on actually getting data from one place, having some data modeling, having some cleaning, so everything is up to standard, to company standards, and delivering those interesting data sets to the business, to the BI teams, with all of the different consumers that are available. This enables an agile process in data engineering, so enables collaboration in your data engineering team. Make sure you can use templates so you don't, when you're working on creating a data flow for an additional data source, you can reuse things because your templates are available. Have the high standard. Have your consistency across environments, so people can, or developers can, have their functionality inside of your dev environment and can test everything out, and then can move that functionality into the next stages. And of course, track your feature development. So when business requests an additional feature, they can track it. Okay, it's still in development. Oh no, okay, it's in test or acceptance. We can check everything out. If everything is okay, we can move it into production, and everybody knows what exactly is running in production inside of the data platform. So I hope the session was interesting for everybody, and I hope that with CI/CD for the data platform, we can enable data engineers, data scientists to deliver actual value faster to the different companies. I don't think there were any questions. I don't see any questions in the Q&A.
No questions so far. So everything was apparently very clear.
Okay. So if there are any questions afterwards, you want to have some additional insights, yeah, feel free to reach out, and I'll be happy to assist.
All right, Koen, thank you very much. I don't see any extra questions come. Oh, there is a question that just popped in, just in time.
Do you sometimes edit your data pipelines directly in code as well? I think if you're a seasoned data engineer, then of course that will be usable, and you know what you're doing. But I think for starting data engineers, yeah, the UI will be the first place to go. Prefer building actual data pipelines in ADF or calling external activities like Azure Databricks? For me, use the right tool for the right job. There are tools like Azure Databricks that are good in certain things, and then it could be that you have a data engineer that can develop amazing stuff in Databricks. Then it can be easier that you have your data factory calling your Databricks to actually perform those transformations. But it's all in using the right tool. Of course, there's also a cost exercise. In most of the time, data factory is more expensive than something that you do in Azure Data Factory, but it depends on the use case. I hope that answered the question. And then a lot of my data pipelines are very similar, same logic, a few different parameters. Yeah, indeed. Yeah, you can use templates to start off, but they're not used, or it's not propagated automatically, so there isn't any dependency between when you created the template and history afterwards. I didn't show you that in the demo, but you can have a lot of, as we probably know, a lot of parameters and variables that you can use inside of your pipelines and inside of your different steps. Now you have global parameters as well, which can be used by the different data pipelines you have. So parameterize your pipelines as much as possible. So you can use global parameters or specific pipeline parameters to make it dynamic as possible when connecting to different data sources or when performing certain actions. So I think partially answers the question, but of course, yeah, you can have templates to have a starting point, but there's no inheritance afterwards when you change your templates. I hope that answered the question.
Seems like
Any other questions?
No. Going once, going twice. No, I think we're good. All right, Koen. Thank you very much. I hope you enjoyed delivering the session. It was very well attended, so thank you for that. And we'll be here again in at 1:45. Okay, see you soon.